In this video, I'm going to explain how to implement grid search using GridSeachCV class in Python. In this video, we'll learn a brief concept of grid search, overview of GridSeachCV class, and Python implementation. Here we learn how to prepare data, setting up base estimator and hyperparameters grid, fitting with grid search, and extracting the best hyperparameters. The main purpose of grid search is to find the optimal set of hyperparameters for a given model by exhaustively searching through a predefined set of hyperparameter values. It ensures that all possible combinations within the specified grid are explored to determine the best performance. Let's look at some advantages of grid search. The first one is exhaustive search. Exploring all possible combinations within the grid increases the chance of finding the optimal set. The second one is simplicity. Grid search is simple and easy to implement. The third one is deterministic. Given the same data and hyperparameter grid search will always produce the same results. The final one is parallelizable. Each hyperparameter combination is independent, allowing for parallel computation to speed up the process. The following are the limitations of grid search. This method is computationally expensive as the number of hyperparameters and their possible values increase. The number of combinations grow exponentially, making it resource intensive. Inefficiency. It evaluates all combinations, even those that may not significantly impact performance, leading to wasted computational effort. Dimensionality problem. With many hyperparameters, the grid becomes so large that grid search becomes impractical when we work with complex models and large datasets. Scikit-learn library provides a tool to simplify grid search. The GridSeachCV class automates the process of hyperparameter tuning, making it easier and more efficient. By using this class, we can define a grid of hyperparameters to search through, use cross-validation to evaluate each combination, select the best combination based on a scoring metric, and parallelize the search to speed up the process. Now let's implement grid search in Python. We'll start by loading the required libraries for this tutorial. Here we use sklearn datasets, model selection, ensemble metrics, and pre-processing. From these namespaces, we import required functions and classes. In this tutorial, we use a California housing dataset. We load this dataset by using fetch California housing function and assign X for feature data, Y for labels. Then split dataset into training and testing sets. Here we reserve 50% of dataset as a test data. Then we implement standard scaling for feature data using standard scalar function. We define a base estimator. In this case, we use a boost regressor class from scikit-learn and define candidate hyperparameters. Here we tune the number of estimators, learning rate, and the loss function. We initialize GridSeachCV by setting the estimator. Here we provide a boost regressor and parameters grid and the number of cross-validation, number of jobs, and verbosity. Here we want to print the logs. Then we fit the grid search using the fit function. After fitting, we can print the best hyperparameters. We can extract it from here, the best params property. Then we retrieve the best estimator. Finally, we evaluate the model on the test data. We use a predict method providing the test data, and we calculate mean squared error and R-squared score also, and we print the outputs. We have finished all the code. Now we run the code. It takes time, so we'll wait for a while. So here is the best parameters found. Learning rate is 0.1 and loss function is linear, and estimator's number is 50, and here is the MC and the R squared values. That's it for this tutorial. In this tutorial, we briefly learned the concept of grid search and how to implement grid search using the GridSeachCV class for regression data. I'll put the link to source code in description. Thank you for watching and see you next time.